Hello, today I'm going to present the project that me and my group worked on for the Artificial Intelligence for Business course taught at NYU Shanghai in the spring of 2019. Our project stems from the paper written by Ralph Neuneier in 1996 called Optimal Asset Allocation using Dynamic Programming. We found the idea in the paper to be very interesting, so we decided to work on this. And it's a very simple idea. So we have a data set that we took from the Oanda platform, and which consists of 15 minutes of foreign exchange data between Euro and USD. And given this data, we want to answer the question, can we use a Q-learning epsilon greedy algorithm to tell us, given an exchange rate that we observe and an amount of money that we want to exchange, should we do that? And as for every Q-learning algorithms, we have to design our state space and our reward functions. So the state space, as mentioned earlier, it's composed of the tuple of exchange rate and the amount that we have. So the exchange rate, we observe it from data, and the amount, it's just something that we set ourselves. So we decide how much to invest. And from the data, we get all the exchange rates, and we bin them into 10 different bins, and also set an amount, we bin it into also 10 different bins. And after this binning process is done, we get this grid, 10 by 10, and in each square, we're in a different state. And for each different state, we're going to answer the question, should we, at this state, exchange all the sum that we have left? And if the answer is yes, we're going to move then to a different state with a new exchange rate. If it's no, we just observe the new exchange rate and we're going to move anyways. So, but then we also have to define our reward functions that is going to be used in the Q-learning algorithm. And our reward function, it's very simple. So our rewards are always computed in the base currency, so which is, for us, it's euros. And it's going to take the future value of our amount, but from that we're going to subtract a little penalty, because exchanging on a foreign exchange platform, it's not free of costs, and it's going to be proportional to the amount that we invest every time. So we have taken that into account, and after we train the algorithm using the data that we got from Oanda, for each square we're going to answer the question, should we invest, yes or no? And if we get an answer, yes, for example, we are going to the next state, which is going to represent a new amount and a new exchange rate. And if the new amount that we have is greater because we made some money than the money we started with, then we're going to put the gain aside and restart from the original total amount that we wanted to invest, because otherwise we would go out of the boundaries of our grid. And so this was the general idea, and then we're going to go into more detail in the code and into an application of this framework.
So in this section of the video, we will explain our implementation of the Q-learning function. So we first define a bin function, which allows us to divide our exchange rates into a certain number of bins. We then bring in our data from our CSV file, which we got from the MT4 trading platform. It's a Euro-USD conversion rate with 15 minutes intervals from 2016 till 2018, which approximately has 65,000 data points. And then we bring in the counter class we saw in class during our Pac-Man exercises, which allows us to store our Q values more efficiently. From there on, we implement our Q-learning algorithm. So we first define a flip point function, which allows us to use our epsilon greedy implementation later on. And then we look for the lowest value in our data frame, and from there on we set 20 bins upwards and divide the exchange rates into 20 different bins. And then we, for every iteration, we go through each data point in the first 8,000 data points. We only use 8,000 in this case because if we use any more, the computation takes quite a while. So for each exchange rate, we want to bin them. So this is what this part and this part does. We do it twice because we want to do it once for the current exchange rate and one for the next exchange rate. And we're going to need both to implement our Q-learning function. And then here, for every amount of possible investment in the range of 1,000, so we basically use $1,000 as one bin. We implement an epsilon greedy algorithm along with the Q-learning function. So this is our Q-learning formula, which is the one we have explained earlier on, and the ones we have seen in class. Nothing different about it. And then from then, we update our Q values depending on the values of the values we get. And if it's higher, it's better for us. And here we bring the Q values into the variable the Q vals. These are all the Q values that we get for each data point and for each amount and each exchange rate bin. So these are the bin ranges we used for this implementation. And then from there on, we connect to Oanda. We were able to find a way to connect our Q-learning algorithm to an Oanda API through an online tutorial. So we have class AutoTrader, which allows us to get information from Oanda while also creating our own orders and closing our own orders. So the important part here is this part where we pick the value with the highest Q value depending on which exchange rate we are looking at, and make the best investment according to that. And if we believe that not investing is a better choice than investing, then we just skip that round. And for around every 15 minutes, the auto trader will close any orders we have. So we will basically at most make one trade every 15 minutes. So here you can see the code is running. And if you go on this side, the algorithm is trading by itself. So if you see here, we started with 100,000. It made a slight profit, but then it's too early to decide whether this machine is profitable or not, since we didn't have enough time to run it for a long period of time. For now, it works fine.